All right, let's get through these notes. Okay, so we've learned a lot about congruent triangles up to this point. Now we're going to try to find some shortcuts on how we can prove them. If we can prove certain parts of it, then we can prove that the entire triangle is congruent. So this property of triangle rigidity just really helps us to be able to do that, because there's certain things that to form a triangle, if certain things are true, then other things can be true that we can elude from it. And so that's really what we're going to be getting at here. All right. And so since if the side lengths of a triangle are given, then the triangle can only have one shape. Okay. So if you have certain lengths or certain angles, okay, there's only one shape really that can be formed, is what it's trying to say. All right. So we have one of our postulates called a side-side-side congruency. So if three sides of one triangle are congruent to three sides of another triangle, then they are congruent to each other. So we can see right here, we got 7 and 7, 6 and 6, 4 and 4. Since all three sides are the exact same, okay, then we can conclude that the entire triangle is congruent using the side-side-side postulate. So when you have adjacent triangles that share a side, you can use the reflexive property, okay, which means that, in this case, BC equals BC. And since AC and CD are the same, and BD and BA are the same, now we got three sides that are identical. Therefore, via the side-side-side postulate, we are able to say that those two triangles are congruent. All right, so we have something called an included angle. It is an angle formed by two adjacent sides of a polygon. All right, so angle B is included angle between AB and BC. And we see that highlighted right there. So we have two segments that attach at a vertex, and they form a triangle. We call that an included triangle. All right, so what that means is that we have another postulate that can help us, right? So a side angle side congruency, all right, is that if two sides and an included angle of a triangle are congruent to two sides and the included angle of another triangle, then they are congruent. Okay, so we can see right here, AB and EF are congruent. Okay, angle E and angle A, and then you got AC and DE. Since those are congruent, we have a side, we have an angle, we have a side, so side, angle, side helps to prove it. And so remember that side, angle, side are written in the order because the congruent angles must be between the pairs of congruent sides, meaning that I could not say AB and AC and then use angle C. Okay, the included angle has to be between the two sides. That's what that's trying to tell us. Okay, so we have another example. So we have certain sides that are the same. XZ and ZV are congruent, and WZ and YZ are congruent. And since those are congruent, and then you have a vertical pair with XZY and VZW, right? Those are vertical pairs. That's Y. Then I have a side, I have an angle, I have a side, and I could say that based off of side, angle, side congruency, that is a congruent triangle. All right, we have another example here, right? So we have a shared side, so PN equals PN, that's reflexive. So this is a little bit more of a proof, okay, to prove that these two triangles are in fact the same. So we have PN bisects, so since it bisects M and N and O are going to be the same. We see that PN and MO are perpendicular, so it's a perpendicular bisector, creating a 90-degree angle. They have a shared side of PN, and so they're going to have a side angle side congruency. All right, so in this case, we just had some variables, and so we had to determine if these actually were. So we plugged in what was given to us, x equals 5. And we see that we share three sides exactly the same lengths. So we can use side, side, side congruency on this example. All right, so let's work out a couple here, okay? So side, 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 or side, angle, side postulates. All right, so we see that we have an angle that's the same. We got a side that's the same. Okay, and we got another side that's the same. Now the problem is this is a side-side angle, which we don't have. Okay, so we don't know for sure if these two sides are the same. So we can't determine that it's side, side, side. We don't have the included angle in between the sides. And so we'd have to say it is neither. We cannot determine for sure from this that it's either of those types. All right, now if we look over on this other side, we got 3 and 3. I got an angle there. That's the same. We got a right angle. Then we got 4 and 4. I got a side. I got an angle. I got a side. So it's going to be a side angle side congruency. All right, if I take a look over here again, I got 2 sides and an angle, but the angle is not included. And so I'm not able to prove anything else with certainty without any given information. So it's going to be neither. All right, I see that I got 6 and 6, 4 and 4, and 7 and 7. And therefore, I got 3 sides that are the same. So this is going to be a side, side, side triangle. All right, looking at these here, I got a shared side right there. Okay, and so I got a side, side. Okay, and so we got to find the value of x. What we can do actually is to set these equal to each other. It was 22x minus 3.6. Okay, I'll switch things around and again 2x equals 3.6, so x equals 1.8. So find the value of x so that they are congruent. Okay, and so which means that these would have had to have been the same, side, side, side. So x equals 1.8. We could say side, side, side. All right, on here, for these to be congruent, okay, that and that angle would have to be the same. So would I have a side angle side? So side angle side. And I could set 6x minus 27 equal to 4x plus 7. And with 2x equals 34 and x equals 17. All right, so just a couple of calculations that we can do. All right, moving on here. All right, we got a couple of more possibilities. So we got an included side is the common side of 2 consecutive angles in a polygon. All right, so I got 2 angles, P and Q, and I got a side in between those 2. So we have an angle, we have a side, we have an angle. And so now we have another postulate, angle, side, angle. So if 2 angles and the included side of one triangle are congruent to 2 angles and the included side of another triangle, then the triangles are congruent. All right, so we have this angle, side, angle. All right, you can use the third angle theorem to prove another congruence relationship as well. And so we've seen that one before, but then we got another one here called angle, side, angle. So if 2 angles and the non-included side of one triangle are congruent to the corresponding angles and non-included side of another triangle, then they are congruent. So we got angle, angle, side. So we see angle, angle, side. This is a non-included. Otherwise, it'd be angle, side, angle, which is what this one up here is. So angle, angle, side is another way of proving congruency. All right, we got another here. So this is kind of the 5th way. This is known as the hypotenuse leg theorem. So if the hypotenuse, which remember is the longest side of a triangle, so hypotenuse, and a leg, that's just one of the other sides, of a right triangle, so it needs to be a right triangle, are congruent to the hypotenuse and leg of another right triangle, then they are congruent. All right, so we can see here AC and FD, that's the hypotenuse, they are congruent. Okay, one of the legs, BC and FE, are congruent. Okay, therefore, we can, using the hypotenuse leg theorem, say that they are, in fact, congruent triangles. All right, so let's take a look at this here. Identify the postulate. All right, I got an angle, I got another angle, and I got a side. So angle, side, angle. That's going to be what I'm going to use to prove it. All right, I got 90 degrees here. I got side, side, angle. Okay, so that can't work, but I do have a hypotenuse and a leg. So this is going to be a hypotenuse leg. But I also have this right here in the middle. So reflexive tells me that's the same. So I could also use the side, side, side. Okay, and so if that is true, I also have a side, I have an angle and have a side, or that to prove it. Okay, so if I had to write a proof to prove these two triangles are the same, okay, then I would start with some of that information and I would just give a list of what I find. All right, this side is congruent to that side, and this side is congruent to that side for the third angle theorem, or it's a vertical pair, or it's a linear pair, or whatever. Those are the reasons I would give and draw a proof to show that, oh, all three sides are, side, side, side is the reason why. All right, so we got kind of a lot of stuff going on here. All right, so we do know that that is going to be the same because they are vertical pairs. So I have a side, angle, side. Okay, that it can work, side, angle, side. Also have a reflexive shared adjacent side, so that could also be a angle or side, side, side triangle as well. Now, we don't know for certain, okay, that is a right triangle. If it was, then I could also use hypotenuse leg. All right, so we're taking a look here and trying to determine if we can use the hypotenuse leg theorem on this or not. So I got the hypotenuse is the same. I got a right triangle, so it's got to be that. I have a shared adjacent side, so that gives me a leg and the hypotenuse. So yes, hypotenuse leg works. All right, so looking at these triangles, okay, I don't know for sure that those hypotenuse are exactly the same. And so, no, I need to know the hypotenuse. Need to hypotenuse. All right. All right, so let's take a look at this one. Let's more talk about it than write out. All right, so if angle FAB, so FAB is congruent to GED, well, that means that these in here are a linear pair, and that's also going to be congruent to one another. And if ABC, okay, is congruent to EDC, then I got that being the same. And if AC is congruent to EC, well, then I got an angle, angle, side. Okay, situation set up, and so this is going to end up being an angle, angle, side congruency. Okay, and we could write that out in the statements and the reason why and all that kind of stuff. But essentially, if we can piece that together, okay, then we can say what the reason actually is. Okay, so write which postulate. All right, I got a right triangle. I got a leg that's the same. I got a shared hypotenuse, so I can say hypotenuse leg congruency. All right, I got a right triangle. Okay, I got these ones the same. I know that these have to then also be the same. Okay, so I have an angle, angle, side because I got that one in the middle. That would work. Angle, angle, side. I also have third angle theorem. All right, so I figured out what that third angle is, so they are congruent. That's another possibility. All right, this is sharing a side, so I know those are the same. So I got a angle, I got a side, but I don't have them in the order that I need. So therefore, it is none of our options. Okay, I got this side being shared again. I got an angle, I got an angle, I got a side. So I got angle, angle, side congruency. All right, so hopefully you're seeing that these are shortcuts to figure out congruency. If I have certain parts of it, then I can therefore determine that they are then congruent. All right, so it says if time. All right, write the proof. All right, so I'll just kind of mark up the graph or the graphic, and that can help us kind of piece together what it would be, but I'm not going to write it all the way out. All right, so I have a 90-degree angle, so it's a right angle. B is the midpoint of AC, so therefore these are going to be the same. Angle E and angle D are right angles. We see that, and we got EB, okay, and DB are also the same length. All right, so I have an angle, I have a side, and so is there anything else that I can prove to be true at this point? Okay, there's not a ton, okay, that we can do at this point to guarantee that we know all the details. Okay, but we have those sides, we have that angle, and it's going to create that angle. Then we could assume that these two are the same, which then would say these two are the same. So we got angle, 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 side angle, in order to prove that that is congruent to one another. All right. Here we got shared side. Here we got a right triangle. So angle 1, and all right, so we got another one right there. That is shared. So we got angle, angle, side as a possibility to prove that one as well. All right, so just kind of speeding through some of that. I want to try to get to this last little bit. Okay, so we have the 5 that we've talked about are side, 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 angle, side, angle, side, angle, 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 side, and a hypotenuse leg. Okay, so we have an abbreviation, CPCTC. Okay, what this stands for is corresponding parts of congruent triangles are congruent. All right, so this is kind of a justification that two things are congruent. So this is a key point here. So it's kind of like you say, oh, well, side, side, side. And so therefore these things are congruent to each other. And the reason is, CPCTC, corresponding parts of congruent triangles are congruent. All it means is that if I have two congruent triangles, then the parts that match up on each, the corresponding parts, are therefore congruent as well. So that seems relatively self-explanatory. So we got some options here. All right, so we got those being the same. We got these being the same. We're trying to figure out, okay, if AB equals 18 as well. Well, this is a vertical pair. So now I got a side angle side. So if a side angle side is true, then therefore it's congruent. So AB will equal 18 miles. All right, so now these guys are the same. Okay. All right, not too much more to go here. All right, so it's saying use those, okay, along with the CPCTC, okay, to prove each. All right, so I'm looking at this. I got shared side right there. So I got side angle side. Okay, and so since I have side angle side congruency, therefore I say that angle A is congruent to angle C. The reason is CPCTC. All right. I got the statement, therefore, and I got the reason. All right. I got another shared side, so I got angle, side, angle. So angle, side, angle. So therefore, HE is congruent to FG. Why CPCTC? Okay. So we're using one of those to prove the congruency, and then we're saying that the statement that they're wanting us to prove is true because corresponding parts of corresponding triangles are congruent. CPCTC. All right, so it's the last step. I'll show you that on the proof here at the bottom. All right, so I got hypotenuse. I have a leg, so this is going to be hypotenuse leg, and so therefore angle K and angle P are congruent because of CPCTC. Okay. All right, I got that's equal to each other. I got angle, angle, side, and so I could also say that, well, I got these must be equal as well. So I got third angle theorem, or angle, angle, angle as well. Okay. And last, okay, I have shared side here. So I got three sides of the same. So side, side, side. So angle U is congruent to angle W because of CPCTC. Okay. So if I use this in a proof, what would that mean? Okay, so the first thing is given. All right, so then UX is congruent to UV. Okay, UX congruent to UV. Okay, that is also given to me. So there's my reason. Nice and easy. All right, UW is UW. Well, the reason is the reflexive property. All right. And so what I could say is I got a hypotenuse and I got a leg that are the same. So therefore, I can now, right off the bat, prove that triangle UXW is congruent to triangle UWV. Why? Because of hypotenuse leg. And so because of that, I can say that angle X and angle V are congruent. Why? Because CPCTC. So it's really just, I'm trying to prove a triangle is congruent using kind of our shortcut reasoning. And then, as I can see here, this isn't saying prove they're congruent, but I'm using the fact that they are congruent to then prove that a certain part actually is congruent as well. So because they're congruent triangles, the parts are congruent. That's why we put CPCTC there at the end. So it's going to be after the triangles are proven. All right, we're not going to go into detail about these last few. And so that's going to be, all right, we're not going to go on to isosceles triangles in those details as well. Hey, just you see that. All right, I got two sides that are the same. And isosceles, and I also have those two angles are the same on isosceles triangles. Okay, so we see that the vertex angle 3. Okay, so A and D would be the vertex angle. Then I got the base angles on the bottom. All right, so that's just some terminology that might be helpful. So we got isosceles triangle theorem. Okay, two sides of a triangle are congruent. Okay, then the, I guess I'll give you a little bit of this just to make sure that you got it. Just the basics here. All right. All right, so if two sides of a triangle are congruent, then the angles opposite the sides are congruent. All right, so we're saying if these sides are congruent, then these angles are congruent. Okay, so if these sides are congruent, okay, then these sides are congruent. All right, that's what we're trying to say with that. All right, the isosceles triangle theorem is sometimes stated as base angles of an isosceles triangle are congruent, just in case you see that. All right, so right here, if a triangle is equilateral, this is a corollary. Equilateral, and is equal angular. Shouldn't be too shocking. Okay, so that means that these are all the same with each other. Okay, and then therefore, if a triangle is equiangular, then it's equilateral. All right, so we can draw some of those corollaries from that. All right, so that's just some kind of basic information we know about isosceles triangles. I won't go into all these proof examples. That's going to be all you really need to know. And so just take a look at those. Make sure you have a decent kind of understanding of those different theorems is the main thing. Just remember a couple things about isosceles, and you will be all set. All right. Thanks for listening.